Assalamualaikum. My name is Siti Nurma binti Ajuzwa. My mention number is TC24005. So today I'm going to present a concise overview of solar energy solutions. We will look at how this technology works, why it is a vital part of our energy future, and the practical challenges we face in its adoption. Solar energy is defined as energy from the sun in the form of light or heat. It is our planet's most abundant resource. The sun converts approximately 4 million tons of mass into energy every second, radiating it into space. Our goal in harnessing this power is to transition away from fossil fuel, which have caused a dramatic 40% increase in atmospheric carbon dioxide concentration since industrial times, driving global climate change. Now, I would like to explain the mechanism behind solar energy generation, which is known as the photovoltaic or PV effect. The photovoltaic effect is the process that allows solar panels to convert sunlight directly into electrical energy. This conversion occurs through the interaction between light and a semiconductor material, usually silicon. The first step begins when light photons from the sun strike the surface of the solar panel. Photons are tiny packets of energy carried by sunlight. When these photons reach the silicon absorber layer, they transfer their energy to the silicon atoms. In the second step, the absorbed energy causes the electron in the silicon material to become excited. Normally, these electrons are held in place within the atoms. However, after gaining enough energy from the photons, they break free and start moving within the materials. The solar cell is specially designed with an internal electric field that forces these free electrons to move in a specific direction. This movement of electrons creates an electric charge difference across the cell. In the third step, as the electrons continue to move through an external circuit, an electrical current is produced. This current can be collected and used to power electrical devices, homes, industries, and other applications. In summary, the photovoltaic effect involves three main stages. First, sunlight photons strike the solar panel. Second, electrons in the silicon material become excited and are released. And third, the movement of these electrons generates an electrical current. This simple but effective process allows solar energy to be converted into clean, renewable electricity without producing harmful emissions. Let's talk about the advantages of solar energy. The primary advantage of solar is that it is infinite and renewable, governed by the laws of energy conservation. Unlike traditional power plants, solar panels do not release greenhouse gases during operation. Furthermore, while there is an initial cost, systems offer long-term financial savings. For example, a typical residential installation can pay for itself through reduced energy bills in just a few years. However, solar energy is intermittent, meaning it is weather dependent and cannot produce power at night. This necessitates energy storage solutions like batteries, which add to the system's complexity. Additionally, the upfront installation cost can be high, and significant physical space, such as a large roof or a dedicated ground area, is required to mount enough panels to power a standard building. In conclusion, solar is the world's fastest growing energy technology, with production increasing by over 40% annually. It is rapidly reaching grid parity, meaning it is becoming cheaper than traditional power in many regions. As costs continue to fall, solar energy will remain a vital pillar for a sustainable green future. That's all from me. Thank you.